All right, welcome everyone. I hope you can hear me. I, 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 I guess so. This is the first live stream that I ever do, so it's a bit of an experiment, and I hope everything is set up correctly. So this just kind of serves as, let's say, a tryout for future live streams. But also, today we want to build a neural network in Minecraft. So on April Fools, I had a tweet out saying my channel is now Minecraft channel, and it was kind of haha. But then people in our Discord started debating whether one could build a neural network in Minecraft, and so I looked up what exists, and it seems like most people it has been done. So, but either they do a little bit, so they do command blocks and things like this, which I don't like, or they do mods, which I also don't like. So, or they do binary computers, so you can build binary computers, but these are way too big. So I thought we'd build a neural network, like an analog neural network, based on redstone. And so I looked up a little bit what exists because of that. And so the base component you see right here. This is a multiplier. So there exist things to multiply. Oh, by the way, let me just kind of introduce redstone a little bit. So this is redstone, right? And if it's this kind of signal in my, I'm not really good at Minecraft, but so this is redstone, and you can see on the right side here where it says power 15. So the signal, that's the signal strength. So this is kind of a source of signal. And then the power is 15, and per 1 square, it decreases by 1. So you can see it's 13, 12, 11, 10, and so on. So we can sort of continuously represent 16 values. And we are going to do backprop. So the plan is to build a neural network first for forward propagation, and then to do backprop, though that might not be today. Today might only be the forward prop because that's already difficult enough. But I have the backprop in mind. So this is built so we can actually train it with backprop, which is going to be crazy. Yeah, I have no idea what this is going to look like and if you know how far we'll get. And again, this is just a bit of a stream test. So I might drop out at any time. Actually, my laptop battery is, even though I'm on a power adapter, it's decreasing. So it might just crash at some point because I'm using way too much power here. Playing Minecraft on 2 screens and streaming, and the microphone, and yeah. And I only have the weak charger for the MacBook. I have the 61 watts. I forgot the 98 watts. Otherwise, yeah, this is going to be over in like 10 minutes. So, all right, all of that said, this is a multiplier. So this is based on a design by RKF Walter. And he has a cool video, and he just displays this a little bit, and I tried to figure out how it works. So we're going through building one of those, and then yeah, we'll see what we can do. So we want to build a neural network with 1 hidden layer and 2 neurons. For that, we need and 2 inputs. So we have 2 inputs, 2 neurons. So we need 4 weights. This thing here multiplies 2 numbers. So one of them is going to be an input, and you can see. So if you flip the book here, it's maybe some more redstone basics. Yeah. So this here is a comparator, right? And it can do many things. One of the things it can do is it can read the block in front of it as a signal. So it can read many things. For example, it can read a book. So if the book is on page 5 of 15, the output signal here is going to be strength 5, and so on. So it just reads the page of the book, right? So that's going to be, so we can use these books as preliminary inputs. You know, we want to connect up these things eventually. But so here, this is on, let's say this is 2, right? Let's put it on 3. And the other input is down here. So that's 2. Let's put it on 4. And we press this button. The thing does whatever the thing does. And then you can see right here, the signal strength here will be 3 times 4 will be 12, hopefully. So there's 1, 2, 3, 4, 5, 6, 7, 8. I'm confused. We'll just look at it. It's 12. It's 12. Great. All right. So we have a signal strength of 12. So this thing multiplies. And we're going to see what it does. You can see it has a bunch of pistons. It has... So I can also stick the button here. We can activate it. You can kind of see what it does. It's actually pretty smart. Let me just set it to daylight. So we'll build one together. And yeah. All right, so what we need to start. I actually have a schematic. I have a scheme on a piece of paper because I'm dumb. But I think I've understood how it works. So we'll start out. You can see it's kind of a, I think it's a 7 by 4 by 6 design. So we'll just kind of put one up here. This is kind of the, just mark the edges right here. That's the edge right here. So that's, and then it's 1, 2, 3, 4, 5, 6. Maybe like this. Okay, so what we'll do is we'll take an input signal, right? You can see the lantern is there. Sorry, the lectern. I don't know how that's called. And I'm sorry, I'm a bad streamer, so I try to pay attention to the chat, but I'm not very good at it yet. So we'll set this to whatever, 3. So this comparator here is going to power this block. And then we are going to feed the signal into this block. And then the signal is going to go over here with another comparator. So the trick with comparators and wire is that the wire, it's okay if it's for one block, but the wire will lose power over time, while the comparator will not. So you can make a wire out of comparators like this, and the signal won't lose power. Yeah, there's also a repeater, which will always power the signal back up to 15, no matter what you do. All right, so this is the input, and we'll also already configure the output. So the output is going to be here. This block is going to be the output. So we grab the output here. The output flows out here. And the comparator here is going to power the output. Now, with these comparators, another thing you can do is you can subtract values. So if you have, for example, a comparator like this, and there's a signal here, let's say that signal is 9, and you do something like this. So this is just a wire. So, and this is 5. If you side feed a signal into a comparator, it can do one of two things. So this is just comparing. So this will give you an output signal if the input is greater than the side input. So here, as you can see, we have an output signal. Now this is 9, this is 5. If this is 10 or higher, you won't get an output signal. So that's kind of a gate which we can use for something like a nonlinearity. And then you can put it into subtract mode, in which case, so this is 9 and this is 7, in which case this should be 2, and you see it's 2. So you can subtract stuff. You cannot add stuff. So you have to work around a little bit of adding. So adding becomes twice subtracting different values. Yeah. So we have the output here, and the output is going to be, in the whole circuit, we'll work with 15 minus the value we'd like to output. So what we need is a constant signal of 15. And this, you can do it in many ways. You can do one of these, like you can do one of these lecterns right here. Or what you can do is you can get a hopper like that. Let's put that here. You can get a hopper and you can just fill it up with, so here I have a bunch of shovels. So the comparator measures how full the hopper is, right? If the hopper is just a little full, then the comparator, so the signal will be proportional to the fullness. So we filled it whole, so the signal is 15. And what we want to do is we just want to subtract something from that, right? So if we work with the subtracted signal here, we'll get that. I'm going to check. Yeah, my battery is going down. I'm really sorry. Yes, it's going to have TPU support. What are you building exactly? This AI, no, it's not going to play Minecraft. That's a while. We're just trying to build a neural network in Minecraft without any command blocks and any mods. So that's that. Yeah, I'm really not sure how I can extend my battery life here. I'm gonna turn the screen brightness of my stream screen down, way down, so I will only very occasionally be able to look at chat. I hope that's going to extend the battery life a little bit. I hope. We'll see. Otherwise, this is very short. Okay. In any case, you have this here. And now here comes the what I thought was genius. I guess if you play Minecraft, you might know this stuff, but I thought this was just crazy genius. So if you look over here, where I already have one of those, the contraption we're going to build is going to look something like this here. And this is a memory cell. And what it does is it remembers a value. And so the way you do it is you want to do two comparators side by side like this. And then each one feeds into a block. So each one powers a block. Each one forwards the signal it gets into a block. And then the block will in turn power the redstone next to it. So you can see it's a loop. It's a closed loop. Now what happens when you feed signal into that loop? It remembers the signal. So it remembers the signal strength because the signal travels through the comparator, powers the block, powers the redstone, comparator, block, and so on. So this is a memory cell. And I thought that was genius, but again, you play Minecraft, you probably know. So what we are going to need to do, as you can see right here, we put this one in subtract mode. Now, whatever signal comes in, right, we subtract it from 15, and that's going to be our output. So right now, since we've powered this thing, it's 15. If we reset it, it's 0, and then the output is 15. Okay, cool. So this here, this is going to be our reset. So here we want some kind of whoops. I'm not good at Minecraft, just say. So here, this torch, nope. If this lights up, this is going to reset the circuit. See right here, reset, bam. That was stupid. That was stupid. Okay. All right, so far, so good. Now, how are we going to achieve this? So you can see here, and how is this even going to multiply? So the way this multiplies is down here, it remembers a value, right? So what we're going to do is we're going to reset and then feed in 15 minus the value we want it to output. So if you can see here, this resets, and then after that, it feeds in. So when this block here comes down, it completes the input circuit from the input signal to the memory cell, and then that feeds in as a side input here to the comparator into the memory cell, okay? So the longer, this is going to be timing based, the longer this piston stays down here, the more signal is fed through here into the memory cell. And I can also show you how that works right here. So if you set this to subtract mode, right now it's 15, right? Because we've reset this. So let's say we've reset it. Okay, we have 15 in here. If we just really briefly power this, maybe you can see, it's still 15. If we put some power on this, let's put some a bit longer. Now it's 0. Okay, we've, now it's 0 again. Okay, we might need to be a little bit faster. Nope. Maybe I'm doing something wrong already, or I don't understand something. Okay, but that would be the idea. So, because we feed in 15, right? Yes, if we feed in a value less than 15, so as the longer we make this, the weaker the signal gets. So let's reset the circuit. Bada boom, bada bang. It's reset, and we just briefly apply the signal. So you can see that the value here, it dropped to 10, right? So this whole memory circuit has 10, so the output is going to be 5, 15 minus 10. So you can see the output is going to be dependent on two things. First of all, how strong the input signal is. You can see I made it weaker by laying a longer wire. And second of all, how long the circuit is established. And the effect is going to be multiplicative. And that is a multiplier, an analog multiplier in Minecraft. And that is kind of the only one I found that because all the other ones are either fixed multipliers, so it's really easy to like multiply a signal by 3, but then you can only do 3. And this one is actually a variable multiplier. So if we can variably control how long this piston stays down, then we can check, then we can control both input values to the multiplication. Okay, chat a little bit. Yes, yeah, there is a mod where you can run this. It's true, but we want no mods. And my battery is going down. This stream is going down any second. I'm sorry. Like I have 2 sources of power. So the USB-C from the display and the charger. And still, yeah, this is going. I might be able to disconnect. 1 second. I can save this. This stream might get disconnected for a little bit. All right. I hope this is better. Okay. So back to business. All right. So our goal is going to be to have that piston here somehow be time dependent, how long it is down. And this time dependent on the input of the higher level. So we need 1 level up. 1 more. Bim, bada boom. Here, there. Okay. All right. So we have ourselves another input here. including a book. And let's set that to 3. What do we have this on? 3. No, let's set that to 4. Okay. Now, yeah, we want to read the signal with a comparator here. And again, we want to just somehow forward the signal around like this. Okay, so as you can see over here, we're going to have another circuit here on this next level. So first of all, this goes around, turns around the corner here. Then there is a gap, and the gap is going to be important in just a second. And then here we'll just fill out about this. Okay, so there's a gap, and yeah, we'll get to what the gap does in a second. But here we'll do something very similar to what we did before. So for people who are joining the stream just now, I'm going to go out of battery any second. I'm sorry. Yeah. So this here, what it is another memory cell, as you might be able to see. Now, the point here is that before we fed into a block there. So we did this. So now if we complete the circuit here, you can see it saves the value. But if we do this, since redstone wire loses value over time, if it's longer than 1, this is too long, so it's going to lose 1 value per cycle. So if I complete this, you can see, yeah, maybe not. Let me power this with 15. So as soon as I take this away, you can see it loses power over time, depending on how strong the input signal is. So if we can, feed this input signal for a controlled amount of time, take it away, then this loop will run as long as there is input, signal. So it will run longer if the signal is higher. And then all we need to do is we need to push the piston down, depending on how long that is. So let me place a piston right here. Bang, boom, and that's it. So if we power this, you can see it piston down long. If we just complete it, so this signal here is like, what, 4 or something, or 3? You can see it's very short, right? Compared to if I do this and then take that away. It stays down very long. And that's going to feed this signal into this loop right here. Yay. Okay. So the rest is just kind of wiring up these circuits into other circuits. There is one piece missing, namely we need to complete this circuit here for just enough time to have this signal travel through into this circuit. So the way we're going to do this is, again, with another piston. So here there's going to be a piston about right there, filling this hole. So if this piston extends, this circuit is going to be, this is one too low. Here. If this piston extends, this circuit is going to be completed, and you can already see this thing extends. If I take this away, it comes back. If this is a lot higher, like 15, and if I take it away, now it stays down for much more longer. Yeah, cool. So we are very close to completing our multiplier. As I said, we just kind of need a way to activate it. So we need a way to, first of all, we need to reset this thing right here. So this is our reset of the lower thing. We need to activate this first and then kick off the whole this thing, then this thing, then this thing. So we want first just a kind of a pulse here, and I need one here. All right. So we want a pulse here onto this thing. This turns off this torch. This, no, this should be off by default. Aha. One here, one here, one here. This looks better. One here. Okay, so this is our default state, right? So this is off. We're just going to flick this on for a second, which is going to reset this memory cell. How do we do that? I don't exactly know myself. I have to go and cheat and look over here how I did. Oh, sorry. So this, again, this is from RKF Walter, the design. So this is not mine. I just modified it a little bit because his was much, much more extensive. And also, again, for the people who just joined, my battery is going to go out in any second now. I'm sorry. Okay. So this is a neat little trick with a piston right here. So if you have a piston shoving up and it has a block on it, it will generate a very short pulse as it travels up. So this piston here, when it's down, you see nothing. And then when it goes up, maybe I can show it like this. It gives a very short pulse. No? Uh-oh. Well, that was a mistake. So maybe I can place it here. Yeah. So if you power this block, I think, or maybe this torch powers this block, and then as it travels up, it just briefly gives a pulse here. In any case, there is a short pulse when this travels up, and that's what we're going to use to power this block. And there's also a bit of a delay, which is really nice. I don't know if you've seen this, but there is a delay before that pulse comes. So that's exactly what we need, right? We're going to need a torch here. That's going to be our reset gate. It flicks on immediately, and then after a little bit of a delay, and we'll build in a delay with a repeater here, we'll activate this piston, which will time-dependently activate this piston. All right, now we just need to do it. I suck in Minecraft. Okay, on this, sticky piston here, block here. I've already screwed it up. So, piston here. That goes up. It needs to have a block on top for this to work. And that's going to power a repeater here. And we'll set the repeater to 4 ticks. And that's going to power the redstone, which is going to power this thing. Let's try. Do we have everything? I feel like a lot of this stuff is just for show. We should be able to have here now. So bot. Bot. So we have a button, and beautiful. You see the signal decaying? Absolutely pretty. All right, so let's try it out. So we multiply 3 by about... You can see we're very limited here because we can only go so far up, because 15 is our limit. So 3 by 2. Press the button. And our output signal should be, what's 3 by 2? 6. Our output signal should be 6, and it is 6. Absolutely beautiful. So we made it. Cool. So we have our thing. I'm just looking a bit at chat. I'm using OPS encoding. No, the problem is my laptop here is too weak. So maybe you can help me. What kind of encoding am I supposed to use? I'm using 4500 as a bit rate. I'm using X264 as an encoder. And I have a 160 audio bit rate. So that's, those are my settings. What do you recommend? And I have a very fast encoder preset. Should I put that on ultra fast? Yes, I'm streaming on a MacBook. It was okay at the beginning of the stream. Yeah, I'm sorry about that. I'm at 6% battery. I think it's in kind of, it might be on power save mode now, right? Yes. I probably should have switch between graphic modes for better battery life. No. Optimize video streaming while on battery. Put on ultra fast preset. Yeah, sorry. First time live streaming. Okay, ultra fast preset, lower the bit rate to, I don't know, 2K, maybe. Do I need to restart the stream to have this effect? 1 second. All right, we're back. Let me know if the frame rate's better now. I'm just gonna continue for like 4 or 5 minutes and then we'll see again. Okay, so while we're here, this is now working. This is a working multiplier. So the next element we need, you can see over there, is, so now we're multiplying two numbers, so we're super duper limited. So like 3 times 4 is probably like the highest of feelings. Otherwise we overflow and we're just capped at 15. So what we need is, of course, we don't not only need a multiplier, we also need sort of a nonlinearity, right? So what we do is, first of all, we're going to use the ReLU nonlinearity because it's the easiest, and we can implement it very cleanly, actually. So I told you about this subtraction mode for the comparator. What we can do is we can have one of them here, and we can just subtract any number from the signal we're getting. So we put this in subtraction mode, and I chose, what did I choose over here? I think I chose 6. So the reason we're subtracting 6 is we want the nonlinearity. So whenever our signal is from 0 to 6, it's just going to be 0, right? If it's 7, it's going to be 1, 8 is going to be 2, and so on. But then we also want to, so now instead of from something to 15, we're now decreasing the signal. We also, because if we multiply in this layer of neural network and then add, our number is going to get bigger and bigger and bigger. We also want to divide it a little bit. And that's this thing right here. This is going to divide the signal. And that's also pretty smart. I found this I found a variant of this in various forums, and what it does is these are repeaters. So these will, whenever there is any signal, they will output full power. And that might seem a little bit counterintuitive to what we want right here, but you're going to see. So let's say we have a repeater here, and let's make the input signal, well, what we'll do, 3 times, what do we have here? 3 times 3, 9. Yeah, sure, that's cool. All right, let's multiply. Our signal strength should be 9. It is. Great. So this is, again, sorry, we're going to subtract 6 here. So this is 3. Now, whenever this repeater detects any signal, it's going to output full power. You see, that's super bright. That's 15. Three to 4 FPS. I'm very sorry. Yeah, I might just charge up a little bit. It's actually charging now, just a tiny bit. So you know what I'm going to do? I'm going to take a break for 20 minutes or so, not use my computer, then come back, and then we're going to do another stream. Sorry, this is the experiment. All right, see you in like 15 minutes.